So, hello everyone, my name is Xue Chen from University of Alberta. The topic I'm gonna present today is about non-productive time reduction in offsite construction with a predictive analytics approach using deep learning. This work is completed by myself and my colleagues Weining, Zeng, Runcong, and my supervisors, Dr. Ahmed Bouferguene and Dr. Mohamed Al-Hussein. I will introduce my work starting from the introduction to the background. When we talk about the productive management, there may be several terms coming into our mind. For example, offsite construction or modular construction and lean construction. So can we make an integrated application of offsite construction and lean construction to further improve the productivity? For offsite construction, it's commonly thought that this kind of offsite construction method should be more efficient comparing to the traditional construction method. And for lean construction, it emphasizes on minimizing waste and improve the efficiency continuously. And according to our manual observation in practice for the offsite construction processes, we found that there are still some non-productive challenges existing in the process, such as the waiting time for material, waiting time for worker, waiting time for machine, empty workstation, idle worker, and the negative variances. So how can we improve the productivity for offsite construction process with lean construction? This kind of problem can be served with computer vision models and some deep learning predicting models, especially with the wide installation of cameras in the construction sites. It has been more convenient to collect the videos from the construction sites and facilitate the application of the computer vision models in construction management. However, from the previous research, we found that the application of computer vision models in productivity management mainly focus on cycle time calculation, construction productivity calculation, or the comparison between the as-built status and as-planned view models. There is a lack about analysis of non-productive time and the timely feedback to non-productive problems. So the objective of this study is to develop a data-driven framework to detect and predict non-productive time in offsite construction site. We use computer vision models and deep learning predicting models to recognize and predict non-productive time from the construction process and interpret the results to suggest lean process improvement strategies. For example, we may take proactive strategies to minimize idle time and boost productivity for future construction processes. To achieve this objective, the development methodology mainly includes the following parts. The first part is to get the result, the non-productive recognition from computer vision models, and use these results as inputs to deep learning models. And the second part is about data processing, including the missing data replacement and the outlier removal. Finally, with the clean data, we will conduct feature selection, feature encoding, and deep learning model training and validation. For the first part, data collection, we select an offsite construction factories with the cameras installed for the floor manufacturing in the factories, and used the ULV model for object detection. The detected objects, including the workers, machines, and materials in the offsite construction factories. And we use the backtrack model to get the maintain IDs of moving objects across frames. Finally, from the videos we collected from the offsite construction factories, we try to identify several types of non-productive time, including waiting time, idle time, negative variances, and rework. And we make some spatial analysis, for example, with the work positions and density, to try to propose some optimized strategies for productivity improvement. For the second part, data processing and feature engineering. After we get the non-productive labels from the computer vision models, we will firstly make data processing The first step is to make some fine-tuning to the non-productive time, the results from the computer vision models. For example, for the idle workers, we only send that the idle time which is more than a threshold as an abnormal non-productive time. And for the empty workstations, which is no one attending in that workstation, it's only thought as the empty workstation when the non-productive time exceeds the threshold. With the outputs from the computer vision models, we try to processing the dataset with some data cleaning methods, including the missing value replacement and the outlier removals. For the missing value replacement, we use the context-aware field method. For example, for the worker which get out of frame and disappear from the dataset, we will replace this value with a new reasonable value with the context-aware method. We will analyze the layout of the factory and try to predict the trajectory of the workers according to the task sequences and replace the missed values with a reasonable value. And for the outliers, sometimes the position of one object may have a sudden jump. For this kind of outliers, we will remove from the dataset to ensure the accuracy of the predicting model. This kind of outliers may caused by the errors of the detecting model and the tracking models. So after we have the cleaned dataset, we will move to the key feature selection. From our cases, the top contributed features include work status, number of workers, coordinates, and object classes. So after we remove some less useful features, the final version dataset has about 50,000 reports and with 17 features selected for the predicting of the non-productive time. And with the clean dataset and the selected features, we will make feature encoding to facilitate the training of the predicting models. So with the clean dataset, we use random forest model and deep learning model to predict the non-productive time. The performance of these two models can be found in the table. For the accuracy, the deep learning model performs about 76%, and the random forest model has about 62%. And for the F1 score, the deep learning model has about 78%, and the random forest with about 70%. Combined with the practical construction processes, we think the reason why deep learning model performs better than random forest model is that deep learning model is good at handling spatial-temporal interaction, such as worker movement and multiple step tasks, while random forest struggled with limited trade-off on nonlinear relationships. For example, for the workflow transition, deep learning model can identify that there are often some non-productive time existing in the preparing new work. And for the joint tasks, such as the two workers connecting joist and panel, deep learning model can find that the delays can be always flagged in this activity. And based on the results for predicting of the non-productive time, we propose that maybe we can use lean principles, lean thinking to make some more improvement to the construction processes. For example, we can make some real-time monitoring based on the non-productive time recognition and the predicting, and give the project managers a warning system to help them to make dynamic task scheduling and make equipment maintenance to reduce the non-productive time accumulate and make further process improvements. In conclusion, this study has demonstrated a computer vision-driven predictive framework for identifying hidden inefficiencies in outside construction site. And we use the deep learning model to predict the non-productive time to the outside construction processes. And finally, we try to add in the lean principles to give them effective methods for reducing waste and get guiding improvements. For the future work, we think we can expand our feature set by adding more factors may affecting the non-productive time predicting and improve the performance of the model. Also, the development framework can be used in different construction scenarios, such as steel rebar fabrication, precast concrete, and on-site installations. Firstly, we can take more lean methods to enhance the productivity and explore its application in this framework. And here are our references. Thank you so much.